So the second method of sketching a straight line is what we call the gradient intercept method, right? Gradient intercept, which is actually quicker, right? So what do? We look at the gradient, sorry, the y-intercept. We look at the y-intercept, and where do we get it? We get it from our equation, and then we apply that rise over run method. Okay, so this is quick. There aren't much calculations involved. Okay, so we're sketching the graph now. We know that my graph cuts the y-axis at -2. So this is my -2, my y-intercept, right? What is the gradient of this function? The gradient is 2, positive 2. Remember, y is equal to mx plus c. So this here is my gradient. Okay, so what does it mean? It means that if I want to find another point that this line goes through, I must rise 2 and run 1. Why am I saying that? Because 2 is 2 over 1. Okay? So it means that if I want to get to the second point, I go up 2 units. So it's going to be 1, 2. So it's 1, 2. And I run 1. And it's a positive 1. So it's to the right. Okay? So that's the other point. And then I take my ruler. I join these two with a straight line. And it's as simple as that. Okay, let's go through it again. You look at your intercept, your y-intercept, okay, which is -2. And then you ask yourself, what is the gradient? Oh, the gradient is 2. So it means it's 2 over 1. Rise over run. Rise 2, go up 2, and go 1 to the right. So it's 1, 2, and 1 to the right. That's my second point. Join them with a straight line. And there you've got your graph. Okay, so that's how you sketch it. Now, the other thing that they might ask you is they might sketch a graph for you and say, give us the equation. Right, so find the equation. So what do they draw for you? They give you, for example, something like this. Let's say they give you a graph that goes through 6 and 6 on the x-axis. Sketched for you, right? And they say, give us the equation. Now, you know that the equation must be in this form, y is equal to mx plus c. Okay, the c is the y-intercept. In other words, where does the graph cut the y-axis? Okay, in this case, you can see it cuts it at 6. Right, so this means that my y is equal to mx plus 6. All that's left for you to work out now is the gradient, right? So what is the gradient? We can use the equation y1 minus y2 over x1 minus x2, right? These are coordinates of points, all right? So what are the coordinates of this point? This is 6, 0. And what about this one? This is 0, 6. So let's substitute. Let's call this point 1 and point 2. So y1 is going to be 6, y2 is 0, x1 is 0, x2 is 6. Okay, so that's a 0. So 6 minus 0 is 6 over -6. Okay, and that is simply equal to -1. So the gradient of this line is -1. Now this one was nice and easy because the y-intercept was given there. Let's do another example where they don't give you the y-intercept. So again, we need to find the equation. Okay, and they draw it for you. They give you a sketch. Okay, I'm gonna make this up. Let's say this one goes like that, right? And they give you the x-intercept. They say that this is 4, and they give you another point here. Let's say this point is -2, -6. Okay, -2, -6. Let me write that properly. And they say find the equation, right? So we know that it must be in the form y is equal to mx plus c. Right, so we don't know this, so we can't simply put it in, all right? But we can work out the gradient, okay? Because remember, when you're working out the gradient, the equation of a line, you need to find the m and you need to find the c. The y and the x are always there because this story is about x and y, so they are the characters in the story. These ones will always be in your equation. You just need to work out these ones, right? So how do we work out the gradient then? Gradient is y1 minus y2 over x1 minus x2, right? That's the coordinates of point 1, and the coordinates of point 2 would be 4, 0. Okay, so let's substitute. If this is my point 1, my y1 is -6, my y2 is 0, x1 is -2, x2 is 4. So that is -6 over -6. So it means that the gradient of that line is 1. Okay, so we know our m now. Y is equal to 1x plus c. Now we need to work out the c, which is the y-intercept. It's not given in my sketch. So now I want you to think of this. If I want to work out c, it means that I need to get values for x and y, because I can't work out c with 3 unknowns. All right, so I must have only one unknown. Right, so I need to get an x and a y. Where am I going to get the x and the y? So you're going to take any points, the coordinates of any points that lie on this line, and you're going to put the x coordinate there and the y coordinate. So any of those two, let's take that one there. Let's substitute -2 -6. So we're going to substitute -2 -6. Okay, and so let's do it. Where I see a y, I'm going to put a -6. Where I see an x, I'm going to put a -2. Okay, so it means that -6 is equal to 1 times x is -2 plus c. Let's simplify this. -2 plus c. Now I've got a beautiful equation with one unknown. Solve for c means I must take this 2 over. When it gets to that side, it's going to be a positive. So it's -6 plus 2 is equal to c. So it means that my c is equal to -4. Right? So, therefore, the equation of my line is y is equal to 1x, or just x, minus 4. Remember, this -4 means that this point here is -4, where the graph cuts the y-axis. Okay, so we're almost done now with this. Let's just do a vertical graph and a horizontal graph. Again, let's say find the equation. Let's do that one there. Let's make this the vertical one. Okay, and it cuts my x-axis at -7. Right. Remember, earlier, a vertical line has an undefined gradient. Right. I don't know if you can see that. Let me draw it here. There, -7. A vertical line has an undefined gradient, so the equation of a vertical line will always just be x is equal to wherever it cuts the x-axis. So in this case, it's x is equal to -7. It's the equation of that line. Okay. Remember, the equation of a vertical line will be x is equal to wherever it cuts the x-axis. Okay. So if my vertical line was there, let's make that a 3. It would mean that the equation of this line is x is equal to 3. And on it goes, right? And let's look at a horizontal line. This one cuts my y-axis at 4. And let's say this one here cuts my y-axis at -2. The gradient of a horizontal line is 0. So it means that the middle term, this is 0. So it means that this term falls away. Okay, and you are left with y is equal to c, and c is where it cuts the y-axis. So it means that the equation of this line is simply y is equal to 4. The equation of this line is simply y is equal to -2. Okay, so any horizontal line, the equation thereof is y is equal to wherever it cuts the y-axis. The equation of a vertical line will be x is equal to wherever it cuts the x-axis. All right, so I'm about to end this video now, but I want to maybe give you something to do. All right, just two graphs to sketch. All right, and maybe give you graphs that I've sketched, and I want you to find the equation. So you can do them and maybe post your answers in the comment section when you get the time. All right. So this is going to be your homework. Grade 10s. So you will post your answers in the comment section, or if you want to ask questions about how to do this, just put it in the comments and then I'll reply. Okay. So this is the homework. If you have the time, please do it. Number 1, sketch the following. A, let's say y is equal to -1x or -x plus 5, and then sketch y is equal to 2x minus 3, right? And then number 2, find the equations. Let's say A, they give you this. They say this is 2 and this is 4. So they want the equation of that, right? And then for B, okay, they say this here is -3, and they give you another point in the middle of nowhere. Let's make it 1 and 5. Okay, so I want you to find the equations of those two and sketch these two for me. Okay, so you can just take pictures, post them in the comment section if you can, or type them out, whatever you're comfortable with. All right. Okay, so that's it now on straight lines or linear functions. So catch me in the next video where we'll be looking at the parabola. All right, good luck with all your preparations.